Hi, this is going to be our first video. We're going to start chapter 1, and this will be chapter 1, section 1. There's going to be 6 sections in chapter 1, so we'll go through. I'll do a video for each section, and we'll get started. So, chapter 1 as a whole is a fairly straightforward chapter. The first 4 chapters, in fact, are going to be mainly review for you. It should be concepts that you've heard of, and we'll be exploring them kind of more in depth, kind of going into more information about them, but there shouldn't be a lot of stuff that's completely brand new that you've never heard of. And chapter 1 is a lot of vocab and a lot of concepts. So we'll start with that. This first part here, a lot of vocab, and isn't really like a math class. It's going to be a lot of sociology stuff. If you've taken AP Psych, or sociology classes like that, you've probably heard a lot of these terms before. But let's get started with some definitions. So we start off statistics. It is the science of conducting studies to collect, organize, summarize, analyze, and draw conclusions from data, or to answer questions with a certain degree of confidence. Statistics is broken up into 2 kind of big chunks that we'll talk about a little bit later. One of them is that analyzing piece, and the other is the drawing conclusions piece and kind of predicting forward. And when it comes to with a certain degree of confidence, we'll talk a little bit more about that. That's when we're kind of looking into the future. That's the second part of this semester. Data, that is the variables that we look at. So if we're talking about heights, each individual height would be a piece of data. Population is going to consist of everyone in the group that we are looking at. And then from that population, we take a sample from that group. So population is everybody, sample are certain people that are chosen from the population to be in the group, and then each individual person is an individual. And it doesn't have to be a person. If we're doing research about cars, or if we're collecting data on pets or animals or whatever, each individual thing is going to be called an individual, and sometimes they're referred to as experimental units. But typically that does not happen if you're talking about people or animals, things like that. It's kind of dehumanizing to use that phrase, but if you're doing, or if you're looking at research that isn't dealing with people or animals, you may see that term experimental unit come up when they're referring to an individual. When we talk about samples, our data, our statistic, the information we get is only as good as the sample that we create. So if we're trying to do research about how the students at Arapahoe High School feel about a certain topic, in order to get a good representation, we need to make sure that the sample of students that we ask the questions to is representative of Arapahoe High School. If we simply have a sample of 50 students and all 50 students have to be, or happen to be, male seniors, that's not going to be representative of Arapahoe High School as a whole. So later on in this chapter, we'll start talking a little bit about how do we create a good sample, what makes a good sample, what can we do to get rid of some of the issues in sampling techniques and things like that. So the better your sample is, the more your sample looks like your population in terms of gender and age and different types of beliefs, the more that your sample is simply a smaller version of your population, the better your data is going to be. And the better your data is, the more accurate your conclusions about or from the data are going to be. All right, these next 2 questions, if you want to pause this video and then try and answer these 2, you're going to say which of those in A and B represents the population and which of those represents a sample. Okay, if you have unpaused, we'll look at this first one. A, we have all adult Americans, and then we have a survey of 270,865 adult Americans throughout the country. So if we're talking about all adult Americans, that is going to be our population. And if we're talking about 270,000 of them, even though that's a lot of people, that is still simply a sample of that population, with the population being everyone. The sample is simply a subset of that group. Next one, we have all adult students who attend community college, and then we have students who attend night classes at community college. So again, since we're dealing with all the students, that's going to be a population. And since we're only talking about a subset of that group, and that is the group that attends classes at night, that is going to be our sample. Now, when we talk about this sample, students that attend night classes at community college, is that going to be a good representative sample of all of the students at community college? And the answer is no. If we're looking at all students at community colleges, yes, we do want some students that take classes at night, but we also need to have some that take classes in the morning. We need that representative sample. And so we need to make sure that we have students that take classes in the morning, take classes at night, take online classes, take correspondence classes, all sorts of different types of classes to make sure that we're getting a good representation. There could be a reason why students are taking classes at night that may make them atypical or different than students that take classes during the day, and you want to make sure you're getting both viewpoints or data from both sections. All right, next topic, census. The census is a governmental survey that is done every 10 years. And is it intended to be a study of a population or a sample? And the answer is it's intended to be a study of a population. The government runs a census every 10 years. It is required by law that you fill that information out. Every household gets a packet of questions about the survey. You have to fill those out. If you don't fill them out, there will be people that show up at your door, knock on your door, and make you fill it out. And if you don't, it is illegal. It's a crime if you don't do that. So the census that the government gives every 10 years is trying as hard as possible to be a study of the entire population of everyone that lives in America. Now, do you think that we actually get information about every single individual that is in America? The answer is no. This census is as close to being a study of the population, getting everyone as we can do it, but even that doesn't get everybody. And there's several different reasons for that. Some of them are the fact that some people don't trust the government. Maybe they have a compound somewhere and they don't want the government to know how many people are living there or how much money they make. It could be something like maybe they don't have a social security card, maybe, and so they're afraid of the government finding out that they're in America and then they'll be deported, and so they don't want the government to know that they're there. And then there's the other side of it, which is there's a lot of people in America that don't have a mailing address, whether that's by choice or because they happen to not have a home, and so you can't mail stuff to them, or if you find a way to get it to them, there's no way of kind of enforcing the fact that they have to fill it out. So even though a lot of money is spent on the census and coming up with the questions and stuff like that, and it's close to dealing with a full population, it's still not even a full population. So when we're dealing with the two different groups, populations and samples, we have different names for the information that we get back from those. So if we're dealing with a population, then the number we get from that is called a parameter. A parameter is a numerical summary of a population, while what you're more used to hearing about is a statistic, and a statistic is a numerical summary of a sample. The reason you're more likely to hear about a statistic is because it's much easier to deal with samples than it is populations. So read this next example. There's an A and a B, and write down whether you think the information that is given is a parameter or a statistic. Pause the video, and then we'll go over them together. All right. So first one, only 12 men have walked on the moon. The average time spent on the moon for these men is 43 hours and 92 or 43.92 hours. Is that a parameter or a statistic? Since there's only been 12 men and this deals with all of those men, this is going to be a parameter. Now, with all of the stuff that is happening with SpaceX and NASA trying to go back to the moon, trying to set up kind of a space station in between the Earth and Moon and go to Mars and all of this and all of this stuff. If in the near future another person lands on the moon, then that will no longer be a parameter because we've changed. We're no longer looking at the entire population of people that have stepped on the moon. So currently, that is still an accurate parameter, but as soon as someone else goes to the moon, it becomes a statistic because we're no longer looking at the entire population. And the second one, a study of 6,076 adults in public restrooms from 4 large US cities found that 23% did not wash their hands before exiting. That is a statistic because we're only looking at 6,000 or just over 6,000 adults from 4 large cities. There are going to be more than 6,000 adults in those 4 large cities. So we're just looking at a subset of all of the adults that live in those cities. And because of that, we are looking at a statistic. All right, now we're going to talk about the 2 big branches of statistics. The first one is called descriptive statistics. It is what we spend the first part of this class on. And descriptive statistics simply deal with kind of organizing the data and talking about the data itself. So we do graphs, we do tables, we have numbers like the mean, the median, the mode. We can talk about linear regression lines. We can talk about all sorts of stuff like that. We're simply describing the data that we have. And that's what we spend the first part of this class on. The second part of the course is called inferential statistics. And this is the powerful piece of statistics. It's after we've collected that data, analyze that data, and then we take information that we gathered from a sample and we make predictions about how that will turn out if we look at the entire population. So if you get a job in statistics, or if you talk about, or if you hear someone talking about analyzing big data to find a trend or things like that, that is that inferential part of statistics. You're looking at a sample, collect the data from the sample, and then you're making inferences, you're making predictions about the entire population based off of a sample. And that is the inferential part of statistics. There's a little visual breakdown of those 2 differences. And now we have an example or a question. If you go through, read those 2 setups and determine whether or not they are inferential statistics or descriptive statistics. All right, so for the first one, it says, based on current trends in the year 2020, and I need to update this. Let's call that 2025. In order for this to work, we have to be looking into the future. So based on current trends in the year 2025, 148 million Americans will be enrolled in an HMO. Because this is based on current trends and it's looking into the future, I changed that from 2020 to 2025. Because we're looking into the future, this is going to be inferential statistics. So you're looking at what's happening currently, and based on what's happening currently, you're going to predict something that's going to happen in the future. And that is what inferential statistics is all about. And then the next one, the median household income for people aged 25 to 34 is $35,888. This is a descriptive statistic. This is the type of information that we get from the census. That's one of those questions that is on the census survey. It asks about things like age, education level, household income, income for however many adults are in your household individually. All of those questions are asked, And when you see something like this, where it says an age range and a median or a mean income, typically that information is going to come from the census, and it is a descriptive statistic. When we get into this, there are four different kind of elements of doing statistics. So the first thing you have to do when you're doing statistics is you have to come up with a research objective. So why are you going to collect data? If you don't have a question you're trying to answer, or you're trying to find something out, then there's no point of doing statistics. The goal of statistics is to answer a question. So you have to ask a question. Second, after you've asked the question, you now have to go back and collect data about the answer to that question. So you want to find out the average GPA of students at Arapahoe High School. That's your research objective. What is that average GPA? Then step two would be, okay, I'm going to go around and I'm going to collect data about different students' GPA. I'm going to collect all of that data. Step three, once you have that data, you're going to do descriptive statistics. That means you're going to turn that raw data, which is just a list of student names or student numbers and GPAs, and you're going to organize it in a way that makes it easier to read, easier to understand. Maybe you put it in a histogram. Maybe you make a pie chart between how many people have above a 3.0 or above a 2.0, things like that. You find the average. All of that type of stuff is done using descriptive statistics. Then after you've done all that, you get to do the inferential statistics. You get to take data from your sample and expand it out to the entire population of Arapahoe High School. So those are those four parts. And it kind of gives you an idea of where we will cover those different sections in the book. So step three, talking about collecting, we do that in chapter 1. Chapters 2 through 4 are all about graphs and how do we describe the data. So graphs, different measures of center, so mean, median, mode, different measures of dispersion, so standard deviation, variance, things like that. And we talk about that in chapters 2 through 4. You will notice there's a gap between 2 through 4, and then it goes 9 to 11. Those in between chapters deal with probabilities. So that's not statistics, that's a different category. People often get statistics and probability confused. They're often kind of wrapped together, and they are entangled, but there are two different kind of maths involved when you're dealing with probabilities and you're dealing with statistics, and that's why there's a gap in the chapters from 4 to 9. All right, so going back to that step 2 where we have to ask that question and figure out what we're doing. When we get answers, we're going to be dealing with a couple different types of variables. The two different types of variables we will be dealing with are qualitative, which is a category, a quality someone has. So if you're left-handed or right-handed, that's a qualitative variable. Male, female, if you're redheaded or brunette or you have black hair, all of those things are categories. And then the next type is quantitative. That is a numerical value. So how tall are you? How much do you weigh? How many dogs do you have? All of those things are numerical values, and so those are going to be quantitative, quantitative. So those are the two big categories or types of data you get back. You either get qualitative data back or quantitative data back. And depending on what type of data you get back, that determines what kind of descriptive statistics you can do. You can't find a mean, an average, or a median of qualitative data. If I go out and I record everyone's favorite movie, which would be a qualitative question, I can't find the average of everyone's favorite movie. So there's different types of descriptive work and descriptive measures that you can take when you're dealing with qualitative and quantitative variables. And so there's some examples of those two different things. And at the bottom of that, it asks a really good question. Take a second, read that, and then answer it, and then we will go over it in 1 second. All right, so we've talked a little bit about the difference between qualitative and quantitative. Would area codes be quantitative variables? So right now, there are two main area codes in Denver, 303 and 720. Are those quantitative or qualitative, and why? The answer is no. I circled why not, but no, they are not quantitative. And they're not quantitative because while they are numbers, we don't actually use them as a number. In order to use them as a number, you have to be able to do math with those quantitative variables and get information back. So if we look at a quantitative variable like age, I'm 40 and you're 18, there's a 22-year age difference between us because I can subtract your age and my age, and we can come up with an age difference. But if I try and do that with area codes, if I subtract 303 from 720, I get a number. That number isn't useful to me. It doesn't give me any information. So really, the reason why area codes aren't quantitative is because they're not used as numbers. They actually describe an area, hence area code. You don't know anything about a person. It's not an actual number. 303 doesn't represent a number. It represents an area, the Denver metro area. And more area codes are becoming even less useful than that. Before cell phones were around, if you got an area code of 303, you knew that person lived in Denver. But now you could grow up in Denver, get your cell phone in Denver, so you have a 303 phone number for your cell phone, but you go to college in Arizona, which does not have that area code. You don't change your phone number. You keep your 303 number. So area codes are becoming less useful for what they were intended to do because of cell phones, because we are no longer attached to a permanent location with our phone number like we used to be. So that's some of those changes coming through. And also I heard about, and I haven't seen anything recently, but I believe Denver metro area is actually looking at getting another area code. So we currently have 303 and 720. I believe there's talk of a third area code having to be used in the Denver metro area because of how many people live here, how many cell phone numbers there are, because you run out of numbers. There's only so many different numbers you can use with an area code. And so when you run out of numbers, you have to come up with a new area code in order to give out more cell phones. Fun fact, interesting fact, when you go through and you look like, how do they make area codes, or why do these choose certain numbers for area codes? When they were first making area codes, everyone had a rotary phone, which is one of those phones that has a circle basically on the front of it. You have to turn that dial and it goes click, 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 click. And it takes a while to dial numbers. So when they came up with area codes, what they had to do was determine the most populous cities, and that was LA and New York City. And they gave those two cities the shortest distance for area codes, meaning you could dial those area codes the fastest. And that was because they wanted to save time. So AT&T and the phone companies wanted their operators to be able to dial those most commonly used cities as fast as possible. So that's why area codes were what they were when they were first given out, was based on how long it would take to dial. The more populous your city was, the smaller that area code is going to be. If you have any questions or if you're wondering what I'm talking about, look up a rotary phone and see that picture. The bigger the number, the longer it takes your finger to reach the top and the longer it takes to dial a certain number. All right. Next example problem or sample problem we have 6 different questions that you could ask on a survey. We want to know if those answers are going to be qualitative or quantitative. So pause the video, answer these 6 questions, and then we'll talk about them. All right, hair color. So if I ask you what your hair color is my response or your response going to be a qualitative or a quantitative number or answer? And it's going to be qualitative. You're going to give me a color of hair, not a numerical value. Weight, that's quantitative. Again, if I have 2 different people's weights, I can find an average weight that means something, or I can subtract them and see how much more person A weighs than person B. And so because of that, that is going to make it a quantitative variable. C is quantitative, D is qualitative. Now this one here, grade level in high school, is a little bit tricky. It is a qualitative variable. Freshman, sophomore, junior, senior, those are qualities, those are categories. Even if we refer to it as 9th grade, 10th grade, that is a category of grade. It is not a quantitative variable. So that one is another one that can be kind of tricky, but it is a category of school or a category of class. It puts you into a category. It's not an actual numerical value. We don't treat it as such. And so it's a qualitative variable. And then the last one, hours of sleep, that is a quantitative variable. All right. So we talked about our first 2 big breaks, the qualitative and quantitative, and we're now going to break down quantitative variables one more step. And that step is the difference between discrete data and continuous data. For the most part, I would imagine you guys understand the concept of continuous. In other math classes, you talked about drawing a line. You've talked about continuity, maybe, if you've taken a calculus course. The idea of continuous or continuity is you can go from the beginning to the end and draw a line without ever having to pick up your pencil. So in geometry, algebra 2, things like that, we talk about graphing different functions. If you have to pick your pencil up when you're drawing the graph, then it's not continuous. If you can draw the entire graph without picking up your pencil, then it's continuous. Same idea when we're dealing with quantitative variables. If it's possible to get every single possible value, then it's continuous data. So anything that can be measured is going to be continuous data. Think about the speed of your car. You don't jump from 60 miles an hour to 61 miles an hour. There's a gradual increase, a continuum of speeds that you pass through when you go from 60 to 61 miles an hour. So things that are measured are going to be continuous. Height, weight, speed, volume, air pressure, all of those things are continuous. Now, the opposite of that is discrete, meaning there are smallest increases. You have to make a jump from one value to the next value. Money is an example of that. So I can go from $1 to $1.01, but there's not an in-between value there. So in American money, the smallest increase is 1 cent. And so because of that, because I jump from $1 to $1.01, that's a discrete value. There's a clear jump from one value to the next value. Points in a sporting event. So touchdowns in football or points in soccer or goals in soccer, points in basketball, all of those things are discrete. The number of desks in a room, the number of computers you have, all of those are discrete values because they jump from one value to the next. There's not a smooth continuum. All right, and take a second to answer this question as to whether the variable is continuous or discrete. Pause the video if you need to. All right. How long it takes you to drive to school. So when we're talking about how long something takes, we are measuring time. So how long is time? And time is something you measure. And so time is continuous. The number of classes you're taking. The number of classes you're taking is a discrete value, meaning you're taking one class or you're taking two classes, but you can't be taking 1.5 classes or 1.2 classes. You're either in the class or you're not, and so that is a discrete value jump from one class to the next number of classes. All right, that is the end of 1.1. I will start 1.2. Have a good day.